Hello everyone, I am Kanchana working in SNS College of Engineering as an assistant professor in the Department of Chemistry. In this video, now I am going to say about carbon nanotubes. Carbon nanotubes are allotropes of carbon with a nanostructure having length to diameter ratio greater than 10 lakh. When graphite sheets are rolled into a cylinder, their edges join to form carbon nanotubes. It is hexagonally shaped arrangements of carbon atoms that have been rolled into tubes. These tiny straw-like cylinders of pure carbon have useful electrical properties. They have already been used to make Chinese transistor and one-dimensional copper wire. Carbon nanotube properties depend on how you roll the sheet. In other words, even though all carbon nanotubes are made of carbon, they can be very different from one another based on how you align the individual atoms. With the right arrangements of atoms, you can create a carbon nanotube that hundreds of times stronger than steel but 6 times lighter. Carbon nanotubes can also be effective semiconductors with the right arrangement of atoms. Scientists are still working on finding ways to make carbon nanotubes a realistic option for transistor in microprocessor and other electronics. Structure or types of carbon nanotubes. And carbon nanotubes are lattice of carbon atom in which each carbon is covalently bonded to 3 other carbon atoms. Depending upon the way in which graphite sheets are rolled, 2 types of CNT are formed: single wall nanotube and multi-wall nanotubes. Single wall nanotubes consist of one tube of graphite. It is one atom thick having a diameter of 2 nanometer, a length of 100 micrometer. Single wall nanotubes are very important because they exhibit important electrical properties. It is an excellent conductor. 3 kinds of nanotubes are resulted based on the orientation of hexagon ladders. First one, on-charge structure. The lines of hexagons are parallel to the axis of nanotube. Zigzag structure. Lines of carbon bonds are down the center. Chiral nanotubes. It exhibits twist or spiral around the nanotube. It has been confirmed that on-charge carbon nanotubes are metallic while zigzag and chiral nanotubes are semiconducting. Multi-wall nanotubes. Multi-wall nanotube consists of multiple layers of graphite rolled in on themselves to form a tube shape. In the Russian doll model, sheets of graphite are arranged in concentric cylinders. Example 0.0,8 single wall nanotube. In the parchment model, a single sheet of graphite is rolled in around itself, resembling a roll-up newspaper. And double wall nanotube are resistant to chemicals and synthesis on the gram scale by reduction of oxide, solid solution, methane and hydrogen. Synthesis of carbon nanotube can be synthesized any one of the following method: laser evaporation, carbon arch method, chemical deposition. Properties of carbon nanotubes. Kinetic properties. Multi-wall nanotubes exhibit a striking telescoping property whereby an inner nanotube core may slide almost without friction with its outer nanotube shell, thus creating an atomically perfect linear or rotational bearing. Electrical properties. The electrical properties of CNT vary between metallic to semiconducting materials. It depends on the diameter and chirality of the nanotubes. The very high electrical conductivity of CNT is due to the minimum defects in the structure. Thermal conductivity. The thermal conductivity of CNT is very high due to vibration of covalent bonds. Its thermal conductivity is 10 times greater than metal. The high thermal conductivity is also due to minimum defects in the structure. microelectronic semiconductors, conducting composite, control drug delivery or release, artificial muscles, supercapacitor, batteries, field emission flat panel displays, field effect transistor and single electron transistor, molecular quantum wires, hydrogen storage, noble radioactive gas storage, solar storage. Solar storage, waste recycling, electromagnetic shielding, dialysis filter and thermal protection, nanotube reinforced composite and collision protection materials. Thank you.